Hi guys, today's video is called Prime Factorizations and LCM, and I'm sure you'll remember that LCM stands for least common multiple. So the purpose of today's video is to find out how to use prime factorizations to find the least common multiple. Today you'll need a paper, a pencil, and a calculator. The first method that we explored for finding the least common multiple was to create a sort of table where you list the multiples of both of the numbers up until you find one that repeats. So for example, if I'm looking for the least common multiple of 21 and 24, I would list out all the multiples of 21 up to a certain point, and then I would list all the multiples of 24 until I found one that they had in common. This method is okay when you have a least common multiple that is kind of low, but sometimes we get into situations where the least common multiple is quite high, and you don't want to have to do all that work of listing all of those multiples out until you find one that they have in common. There's also a lot of room for error there. If you make a mistake somewhere down here in your table, that sets off all the rest of the values in your table, and you might miss the one that they do have in common because of a mathematical error. So instead, a more efficient method might be to use a prime factorization. So here I have created a factor tree for 21 and a factor tree for 24. That gave me the prime factorization of each of those numbers. So I'm going to write the prime factorization out in expanded form. And I want to look for any numbers that, that show up in both prime factorizations. So I can see in this one, I have the number 3 that shows up in the prime factorization of 21 and also in the prime factorization of 24. I only want to use one of those 3's. So I'm going to cross out the other one, and I'm going to write a new factorization. 2 times 2 times 2, that came from the 24, times 3 times 7. So I used one of the 3's. You see 3 only shows up here one time. And then I use all the other numbers that are non-duplicates. If I multiply this out, I get 168. So the method in 3 simple steps is to find the prime factorizations in expanded form, cross out one of any of the duplicates, or maybe you could think of that as leave behind one of any of the duplicates, and then multiply. So for practice, I'd like you to find the least common multiple of 18 and 20. Come back and hit play when you're ready. All right, here I have the factor trees for 18 and 20. I find that they both have 1, 2 in common. So I keep the 2 that goes with 18, and I multiply 2 times 3 times 3 times 2 times 5, and I get 180 as my least common multiple. Now as a challenge, I wonder if you could use the same method to find the least common multiple of 3 numbers, 18, 20, and 22. Go ahead and try it, and then hit play when you're ready to see the answer. I already had a factor tree and a prime factorization for 18 and 20, so I only had to add a factor tree for 22. When I list the prime factorizations for 18, 20, and 22, I find that 2 is the only number that shows up in all 3. I'm going to keep one of those 2's, so I'm going to cross out the other 2. I don't need them. And then when I write my multiplication problem down here, I'll use the 2, the 3, and the 3, that's right here, the 2 and the 5 from 20, that's right here, and the 11 from 22, that's right here. Multiplying those digits all together comes out with 1,980. You can see how if you had listed all of the multiples of each of those numbers in a table, you would have been listing for quite a long time. The tricky thing when you have more than one is to remember that you only need to keep one of the duplicates. You're crossing out however many others there are. In this case there were 2. In this case there was only 1.